continue this. It's there. Yes, cool. So now when I refresh here, now our nodes showed up here. And I don't know if you noticed, but before it said 9 commits up there, now it says 10. And if we actually click on it, now you can see here something that we just did. We committed 3 minutes ago, this. And if we actually click on these nodes here, we can, again, see exactly what we did. Like we added a new file. And the reason why one is empty, the one is with stuff, is that usually this is used to show changes. And basically the changes is you went from nothing to everything. So so it's very useless right now.
Yeah.
But if and we will do that. We will change just a word in the middle, and then you're going to see like this is how it used to look like. This is how it looks right now. And that's when it becomes more useful. Because again, this was a new file that we just pushed.
Wow.
Yeah.
Do you have only Hive Git repository, or do you have any other repository here?
No. When we were looking at this, for instance, at this view,
yes,
this view is all the repositories, like all the repositories.
So how does it know where to push?
Yes, that's a good question. There. Because we cloned it. We cloned the repository, right, the first time.
Yes.
So basically it says like, oh, the origin, like this entire piece of code came from that URL. And because usually when you go here and you say clone, you get this URL or this URL. It's the same thing. It's just that one is using some keys, the other one is not. So I copied this and I said git clone this, and by doing that, it automatically saves this here. So it knows like every time you want to push or pull, this is where Git has to look for those changes. This is where Git has to check like, again, it's the origin of everything is there. So you can only push to wrong repositories if you change this, and it's possible to change it. Sometimes you might want to change it. That happens. So if you do that, if now we would change this to another repository and we would push, we would just basically remove everything that was there. Of course, there is history. That's also why Git is really good, because people would be able to look back and say like, oh, this guy cleaned everything. This is bad.
The blame key.
Yeah. So you can always track back, but again, this is why it knows where to go, basically.
But then if I have two repositories, for example, I should change every time one I want to push, or I guess
you cannot have two repositories in the same folder. That's
like, for example, you have now hack your future Git,
mm-hmm.
and you clone that, and that's the URL for that.
Mm-hmm.
But for, let's say I have you have home repository, let's say that, and you want to push to that repository. It's enough to change, like you make CD.
Yes.
It's enough just to change the repository.
Yes, because these configurations that you're looking at are the ones listed on this folder. Like these configurations comes from the folder Git in your project.
Mm.
So as long as your project has a Git folder, then nothing like that. That's where it's going to say like, tell me what's the remote. Oh, the remote is this URL. Okay, I'm going to push there. It does not try to go to another folder or anything. So for instance, right now here, I'm on my Active Future Git, right? But if I go here, do I have here Future React? Is this also a Git repository? Yes. Now here, how can I show this? Okay, I'll say git config list. Now this one has a different URL.
Okay.
So each project that you have on your machine has a different origin. It has to, unless it's the. I mean, you can clone the same project 100 times, of course, but that one will always have the same because you cloned it from the same place.
Yeah.
You know, so it has the same reference.
Okay.
That's why you say it's like very dangerous to delete.
Yeah, because then you lose like what was the reference? Like where should I push this stuff to? And I mean, you can solve that problem. It's just that then you need to make sure that you had the right URLs and yes, this is what I wanted. This is, and we will actually do that. We'll see how complicated that can get. But if whatever Git folder folder you are, for instance, if I write git here, it shows, okay, I should not write git status. That should show less. If I go to my Hack Your Future git and write git status, it showed the same message. Now if I go one folder up only, now I'm on a Hack Your Future folder and write git status, it's not a repository.
Mm-hmm.
I don't have a git folder, a .git folder on this part. How to show you that? If I open code here. Okay, so this is how the folder looks like.
Yes.
So it has a lot of stuff, but does not have git on it because it's not a project. So even if you try to write git on it, it says like it's not a git repository. So I don't know what you're telling me to do.
And how you create that folder for Hack Your Future?
I just created normal, like as a regular folder.
Okay, but you don't have git inside. .git.
No. Basically, I have a folder for Hack Your Future, and then inside of that folder, all my Hack Your Future projects. And those projects then have git on it.
Okay, so each repository is presented a project. Okay.
Yes, you can say that.
And then inside that folders where you can manipulate it.
Yeah.
Marco, how do you know the repositories on your local machine? Like, if you are on C or on documents, how would you know that these are the list of folders, repositories on your machine?
That's something you have to do on your own. Basically, how to organize it, basically.
So if I'll go on my C drive and check the repositories I have there, I have to manually do it?
Yeah.
And there's no way that it would list all?
Not with the command line. I'm pretty sure with those graphical interfaces like
yes.
source tree or whatever can try to find, basically what they do is like they try to find where is there a git folder, and if there is a git folder, then it's a git project, and if there is a git project, then I can show to people, yeah, you have a project here, project here, project here.
Okay.
But what I usually do, and again, it's very easy to lose control of what you have, especially if you have a lot of projects and a lot of different things, but what I usually do is I have a folder somewhere, and then inside, whenever I want a new project, I make git clone, and then the URL here, and that basically creates a folder there with the project inside. So then all my projects goes into Hack Your Future, but then inside of it, it's individual ones.
So this Hack Your Future is local?
Yes, all this is local. All of it is local.
Okay.
None of it is here. In here is only the projects.
Okay. Yeah.
And that's something that might be a little bit sometimes confusing because, again, the way I'm grouping the projects is my own responsibility, basically. And again, if you clone a project inside of another project, that's a problem. I mean, you're going to see the problem. We will try that problem. Let me just see if... Okay, we did the git head and git commit. Now, one thing that can also happen, and sometimes you might do it, is... let me see what we have here. temp.js. Oh no, it's a lot. Okay. Now, the other side that we're gonna do now is that now if we go to cd Hack Your Future git, now in the command line we are locally in our Hack Your Future git, and on the browser we are on the internet basically. And now if we say git pull here, it's probably going to tell us that there's no changes, like everything is okay because nobody did any changes, right? But now what we can do is that in here we can upload files, right? You know how to do that.
Yes.
Where is it now? Now this is going to be hard. Okay, I will try another thing very fast.
You don't want us to see what?
No, that's actually usually the regular size. The screen got got changed. Temp. .md. Okay, now the file should be there. So I have this file here, temp.md, that basically only has the date inside. And now I uploading the file on my GitHub, right? And now new file here. And I'll just commit. Okay, so now, as you can see here, we had 10 commits before, now we have 11, because now we also have this new temp.md. And when we go here, we can see that new file here was exactly the message I wrote. And when we click to see the differences, we can see like, oh, there is a new file, temp.md, with that inside of it. That's basically what we did, right? Now what happens is we did a change on the remote, which means on GitHub.
Yeah.
But we did not do that change locally.
No.
And again, that's one of the rules you should always do, is to write git pull before you do anything on your local machine, on your repository. Like, let's say we haven't been on this repository for a very long time. And now we want to do something on it. So the first thing we should do is write git pull. For instance, if we write git status, it says like everything's okay, right? Even though we know for sure it's not, because we know that when we look here, that file is not here yet. So now, if we do some change here, it's okay because it's a brand new file. But what we should always do is this: git pull, oh, not pull, but pull. And now this, yeah. Git pull, depending on how many changes there is on a project, sometimes can be really, really long. Because in here it basically tells you everything. It tells you like how many objects were there, what happened, whatever, and then it says like, oh, I mean, we only had this one, so it says like, oh, one file, one change, one insertion, that's it. And now if we go to our local here, now temp is here. Now we are exactly the same as whatever is on GitHub. And if we write git pull again, now it's going to tell us like that everything's fine, there's nothing there. You are already up to date. So now the reason why I say like we should always do a git pull is because we will try to break stuff, which is very easy to do. And that's going to be this part, merge conflicts. Before we go there, we will talk a little bit about pull requests, which you guys probably already know, but we'll try to explain exactly why that should happen. So, because again, I've been doing everything on master branch, right? Where did I have that? Was it here? Maybe. No, this is more of an explanation of how it works. But okay, let's go to Sketch then. So whenever we did this, whenever we cloned, right? We have a working project on our local machine here called site. But now we want to do changes to it. For instance, I have these nodes here, and now basically I want to check mark them. Actually, they are shown a bit weird. Okay, I actually want to just change how they look like, basically. And I already have content. It's not new content. It's just like I want to change the what is Git. I want to change it to look a bit different for some reason. Now what I could do is that I could just go here and do this. And this is a thing of Markdown that basically creates as if it's like a checkbox type of thing. And I want to do this for all of them. So here. Oh, come on. Okay, that's good, right? We can always do that. And now if we go to our command line and we write git status, now we see like, oh, there is changes there. There is some stuff happened there. And the reason not to use master for this type of things is so that we always have a, let's say, clean source, basically. That's basically what would mean, or one source of truth, basically, which means that this one is untouchable. Nobody can push stuff directly, because imagine now I push all these changes, I commit and push, but at the same time you were doing some changes to it. You know, and then you would have to pull, meanwhile, and you would have to know that I did those changes. And as you saw, like just by writing git status or whatever, your local machine does not know that somebody else did changes and they're on GitHub. So it becomes a bit very hard to work in a team by everybody pushing to the same master. So because of that, there is a thing called branching, which means that even though on our local machine is a copy of whatever is on GitHub, now I want to have an extra copy of the copy, basically, which basically would mean that you would do this. Now text, yeah. And this would be git checkout. That basically has a copy of your site here, and when I write site, I mean code, right? And all of it from this point on is local. Nothing is happening on a big one, on a site. I will just maybe write here master. And the idea is you create a new branch, and again, a new branch is exactly what it means, is a branch, right? So that you work on, you do your changes, and then you make a pull request to master saying like, can this be, is this okay? And that's where like the dialogue between developers comes in, like, oh, maybe we should change this, maybe we should change that. So also, because if you push to master all the time, it's true, people can go to your, people can see here on a commit list what happened, right? But again, it already happened. You know, like if there is changes, it's already in master. It's already like, like it's there. So we need to do changes very fast right now because this can break our website. So that's why pull requests come in, because then, yes, we can check, is it okay, without breaking anything. Like it kind of divides the responsibility. And that's basically what happens here. You have a, you have a place where you can work here. You do the changes to it. So in here, you can do as many changes as you want on itself. And then you make a pull request. Yeah, and now, actually here there is a thing that it's because we have the git clone, and that's not really how it works, because the pull request, since no one should touch master, since no one should work on it, then the pull request does not really happen locally. It actually happens to the main one, because we consider like, okay, if master cannot be touched, and we always have to do a git checkout, a new branch, then we can say master is the remote. Master is the one online all the time. So instead of this happening on your machine, basically, it goes all the way there. So that you also don't have, otherwise you would have a different version of master on your machine than the one that is on a website. So, and the way that that would happen, so now we made the changes to our nodes. And as you probably learned on the video from Benjamin, you should always do a git checkout before doing changes, but you don't have to. That's the truth about it. Because right now, if we say git status, it says that we are on branch master, right? And we have all these changes. But if we do git checkout -b nodes info, and this is the, I mean, basically the command is git checkout make new branch with this name, basically.
So B is branch.
Yeah, I think so. I cannot be 100% sure, but I think so. It makes sense to be branch. And once you actually run that command, it says switch to a new branch called nodes info. And here it just says like you already have changes on your code. It's just so that you are aware that you are changing to a new branch and you already have changes. So now if we do git status, now we say, you can see on branch nodes info and then the modified file here. Now going up here, one good tool also locally that you can have, if you can understand it, like this thing that you're seeing, you see like, oh, there was nothing and then there is this. You can have this locally as well, an overview of what's changed by running, because again, if you run git status, it says like, oh, there is some changes here. And in there it says you can add or you can check out. But if we run our git help, yeah, show changes between commits, commit and working tree, etc. So this diff word is very good. So if we run git diff, just like this, again, it might not be very understandable if you have a lot of changes because everything happens in a command line, and a command line, I mean, everything happens on the left side, you know, like there is no pretty on it. But I guess you can understand that red means remove and green means added. That's basically what it's saying. So, but, and this is something really important, in Git, everything works as a line, not as words. Like you cannot say this word changed. What it always says is this line changed. Because when you say like, what is Git, at the dash, and yes, this is not dash dash because the first dash means minus. So, and this one means plus. So, so in the beginning we had dash space what space is space Git. And now it's telling us that we removed that entirely. And now we added dash space brackets what is Git. So Git cannot understand that basically we only added the brackets in the middle, you know. So it always tells you that the whole line changed. That's how it works. And I mean, there's nothing you can do about it. So you just need to understand that you did not remove the line, you changed the line. So in here, you can already see if you want to commit this and to push it, this is what's going to be the changes that you're doing. So this git diff is really, really good. Okay, I'm going to clear, and just to show, I'm going to change something on, oh, this is the video. I'm going to change something somewhere else on a temp, for instance. So now if we write git status, now we have two files changed, right? It's still the nodes and now the temp. Now if we run git diff again, now it shows exactly the same, but now in here, and that's very important to notice, like if you keep pressing the down arrow, it keeps printing. Also because if there is a lot of changes, you cannot, you know, like it's a lot to scroll. So basically like it tells you like keep clicking just so that you see what happened. And basically in here it says, oh, on the file notes.md, these changes happen. On a file temp.md, these changes happen. But what we can also do with the diff is you can specify the file you want to see the changes. So if we do this, it only shows the changes on a file temp, because that's basically what we told it to do. So it doesn't show all the change, everything. And if you do git diff notes, same, only for notes. So again, the diff is useful, but might be a lot of stuff like that you don't want to see. So it's something to be a bit careful with. Okay, I'll leave this here, whatever, who cares. So now we are on our branch. We did the changes we wanted. Now we write git status. Again, as it says here, you need to add the file, and let's try that. Git add temp, right? If we run git status now, we only added temp. So if now we try to commit and push, only temp is gonna be pushed and committed. So, and you can say like, oh, but this is, it's bad because sometimes I might forget, like I always need to add all. But sometimes you might have a file on your project that you don't want on the project yet. Like you're like, oh, this is still a work in progress or something, and I don't want to push this yet. So you can just add exactly the files you want to add and say like, oh, this one, keep it on my machine. Maybe I don't even want this file anywhere. And that's why you can just specify a file to add. But we will now run git add dot, which basically adds everything. And if you run git status, now it tells us that there is these two files to be added. This type of messages here, I think it might be, you should not worry for it right now. It's just that imagine that now we did a mistake. We're like, oh, the nodes should not be committed. What do I do now? Right? Because now if I write git commit, everything goes. So basically this, you can undo what we just did. You can say like, oh no, we don't want the nodes. So you can say reset head nodes. Now, okay, if we run this, nodes won't be added now again. So for on your machine, on your local Git, you can always do this type of things of like, no, I don't want this, or yes, I want this, or things like that. But we do want the nodes, so let's just add. Git status, everything is there. Git commit, message, pretty nodes. Oh. Yes, so 2 files change, 14 insertions, whatever. But again, now if we run status, it still tells us you are on this branch. And this now is going to be the pretty thing to show. So on a branch nodes info, we have these changes. But on a branch master, we don't, right? If we go here, this is master. So in here, I mean, in here you should probably see maybe the raw. We still don't have those parentheses there. We know that. So what happened now? Because if you write git branch, you can see all the branches you have available. And the one with the star is the one you are right now. Basically, that's how it shows. And then we have master. But you can switch branch by say git checkout, and now we don't write -b, because -b is going to create a new one, but we don't want to create a new one. We just want to switch to master. So, and if you keep an eye on this guy here, now when we press, it changed back, because this is what's on master. So now if we say git checkout nodes info, those are the changes. So right now on your machine, this is nowhere else. It's only on your machine. We already have 2 different things of the same content, let's say. So for instance, if you're doing like on your homework or whatever, like, oh, now you need to add this, you can actually say like, oh, I don't want to break what I have right now, but I want to work on this thing. So you can do a git checkout, you work on that thing, then nothing works. You can always go back to master and say like, oh, no, I don't want this, go away. So it's always like, you always have this opportunity of switching back and forward between branches. But again, this is all local, all in our machine. Nothing is on GitHub yet. Oh, you need to write the whole thing. No. Yeah. Git push. Yes, okay. So it's git push dash nodes info master. No. Make sure you have the correct access rights in the repository exists. What? Okay.
Maybe you have to go on the internet.
Yeah, it might be that. Why? Oh, okay. So if we push, okay. Oh, that's a bad one. Git push dash u origin. Yeah, it's the other way around. Exactly. So git push dash u origin, and now not safe. Yeah, now it auto completes. That's why. And this one might take a little bit. So, I mean, what I was actually trying to write before is that I was writing the other way around. I was considering nodes info a main branch, and it's not. It's like it has to be this way, which means that let's push the nodes info branch all the way up to GitHub in this case. And that's the right way to write it, so that you say git push dash u origin and then your your branch name. And again, this is very similar to what happened when we pushed to master directly. So we uploaded a bunch of stuff, whatever. Then what happens as different is this. So it says that it created a pull request for nodes info on GitHub. And I mean, no, it did not create it yet. You can create by going to this URL. And again, in here is very GitHub specific, but if you're working with GitLab or Bitbucket, it's very similar. It's just like a different URL for their website, basically. But before we go to that URL, we can actually, if we are on our project, usually you will see a message here saying like, oh, 1 minute ago, you pushed this. So you can actually go directly here. But sometimes the website, I mean, GitHub does not have that problem, but if you have a self-hosted Git platform, sometimes it might be a bit slow. So you might not see this message right away. But this message here, you should always see. So what we can do now is that we can copy this. And let's visit this URL. And basically, this is a way to open a pull request. So in here, there's going to be a name and some description if you want. And then if you start scrolling, now down here, you see all the changes that happened. On the left, what was before, on the right, what's going to be now. And if this is acceptable, we're like, yeah, this is cool. Now we create a pull request. And now it goes, and it's creating. The pull request is created, but master is still untouched. Master is still as it should be. And to prove that, if we go here and we say git checkout master, git pull, because now we are on master, so we can pull as much as we want. It's probably going to say it's up to date if internet works. Yeah. And yeah, the changes are not there yet. But of course, this branch, nodes info, is still here, so we can still go there, check out nodes info. And the changes are here. So now usually this step is, for instance, where you get feedback or whatever on your code, whatever. And if everything's okay, what you do is that you merge. Confirm.
But this merge to be not you, somebody else will make it.
No.
Depends. I mean, for instance, if you make a pull request, I look at the code and I say like, oh yeah, everything's fine, merge it. Like, it depends. Like, depends on how the team works as well. So now we merged it. Now when we go to the code on master, it's really slow. And if we go to nodes, okay, now there is those checkboxes here. Like, it looks a little bit different. In there is no checkboxes.
Yeah.
Okay. That looks weird. Trust me, there is checkboxes. You're gonna see it on the video. It's because it's a very small line. Maybe if I zoom in. No, nothing.
No.
Okay, that's so weird.
And here you can, if you push on the plan, you see who did what.
Yeah, in here, for instance, as I said, like there is this blame thing, right?
Yeah.
That you can blame on people. So if you click on it, again, there's only one user working on this project, which is me, right? But if there would be other users, it would show their picture here and whatever, and it would say like, oh, this commit changed this whole block. This commit only changed this. And you can say like, oh, but the notes file commit actually was the whole thing. Yes, but since then, this person, this person did these changes here. And now we're gonna see like, we're gonna do a change per each one of them. So that will create another level of history. And yeah, that's basically why this tool is used, is that you can actually see like, oh, we changed this at this day because of this. So so yeah, now everything is on master again. And if we go to our commits here, we can actually see that there is actually two commits, right? There is the pretty notes one and the merge. The pretty notes was the commit I did on a pull request. But because then the pull request has to be merged into master, that automatically creates another commit saying that, oh, this was merged there. And this is where things might become very complicated, because then we have two commit columns, let's say, one for master, one for your pull requests, one per pull request. So there's a lot of pull requests, but again, people usually don't look at that because it doesn't make sense to look at it. So don't worry with that. Okay, let's go back to master here. Now, again, as I said, you always have to do git pull, otherwise those changes won't come down. And yeah, let's do that, and then let's try to create a conflict on Git, not between us. Of course, now in here we see the changes. The nodes did that, and when we look at the code, it looks exactly how we thought it would look like. Okay, yeah, this one still doesn't show. Now, a classic problem is conflicts. And that maybe I need to, how can I try that? Okay, yeah. So conflicts is like when someone does one change and someone else, and by someone else it might be the same person, does another change. And how come that can happen? So very easy, and now we're gonna do something we should not do, which is do the changes on master. Actually, no, let's do it the right way then. So master git status nothing, git pull nothing, up to date. Now new branch, check notes. So now we are on a new branch, right? And now basically I'm gonna say we already talked about all this, and I'm gonna mark them as checked. And now we are talking about merge conflicts, right? So that's basically the only changes I'm gonna do. So git status, there, git diff. Yeah, those are the changes we did. Now git commit, checked things. I always write -a there, but it's not needed. Oh yeah, this is also, that's why I always write -a, because I've been telling you, and this can happen a lot of times, we committed, but we didn't. Because we actually need to add always before committing.
You need to add a file first?
Yes. And that's why by being used to write, I wrote git commit -am and then the message. because this one adds the file, but if it's a new file, it does not add it. This one only adds the changes to it. So for instance, if you would have a new file and you would say git commit -am, the new file still needs the git add on it. So again, I got so used to write this that I always do, even though it's very involuntarily that I do it. So it basically commits everything for sure. So now if we do status, there, of course, now push -u origin check notes. So now blah, 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 he's going to try to push all our changes. If we visit this URL, oh yeah, now I'll actually show it directly on in here. So when you're looking at Git, again, this thing popped up because we pushed from our local. So not only we could copy and paste this URL, but we can also just go here, click, and this is exactly the same thing. It takes you to the exact same page. So this is also a thing that you can do. And this was the message we wrote, seems correct. And those are the changes we did, seems correct. Now we're going to create pull request. Pull request is there. But now somebody is going to say, you should also check this one, right? Oh God, get away from here. And we added a comment saying like, oh, we should also add this one. Okay. And I mean, I'm doing it myself to myself, but you can imagine the other way around. So I have this message here, like, okay, cool, I need to do that change. Now, the way you should do it is to, you're still on your branch, right? Here, if you say git status, we're still on this branch. So even if you're working in a complete different branch, and let's go to master now, right? New file branch, just because I forgot dash B. Yeah. Like we were doing something else, right? And now we got this notification like, oh, you should change this. Let's actually add a new file on this branch, just to make things a bit more crazy. So we just have a new file here on this branch. If we say git status, there is a new file. Now we have to do some changes to this, right? But we're still working on it. So usually what I would recommend is like, you should commit all your changes to this branch so that there is not, because if now we change branches, and I can show that, so now we want to go back to the check notes, right? So we can just change it, check out, check notes. But now this file is here, and we don't want this file yet because this is for a different thing, a different task. So what we should do is that on the branch that has all the responsibility for that, so git checkout new file branch, git status. So because on this one we want this new file, then let's just add it. Because again, we can do that, and let's commit it. Like this is new.
No, you cannot. You should not, because you make a new file.
Yes, but it's on this other branch, completely separate responsibilities.
Yeah, I mean, like you use AM.
Yeah, but I used the git add before.
Yeah, I don't use that. Yeah.
So now if I move things a bit here, so we see what's happening, and that's things should change once I change branches. So if I say git branch, now I have all those, right? So if I say git checkout master, that file disappeared and those things are empty. If I say git checkout check notes, now all of them are set because that's the changes we did that. If I say git checkout new file branch, now that file is back here because so basically now on our machine we have all these different working solutions. which again might be very confusing sometimes to know where is what and what's happening here. But that's where the diff also comes very handy, because we can compare branches. We can say, for instance, right now we are on a new file branch, so we can say git diff with check notes. So this is making a difference between this branch and that branch. And basically the difference is on the check notes, on this one, we have all of these ones removed, basically, because we can see here, it's true. And on this one, we have a new file with the console log hey, which is true. So if we go to, no, not xgit, git checkout, check notes, and in here we do a git diff with new file branch. This gives us exactly the opposite that we just saw. So if I scroll a little bit up, you can see it's exactly the opposite, because we were comparing a branch from one perspective and then another branch from another perspective. So again, this git diff, it's very useful for these type of cases. Like if you have a lot of branches and you don't know exactly what was there, then you can use it for this feature. Yeah, but we still need to do that change that that guy commented there. So now we're gonna do a very big error thing, which means git checkout master, and we don't touch master, right? But new check notes, and I forgot -b again. So now this is a complete new branch that we did. And because that guy told us to do those changes, now we're actually doing all the changes again, right? So he's going to push the whole thing. He's going to create a new merge request. So basically now what we did is that we created another merge request, right? And on this one, we had a note to change this. Oh, this one should also be checked, right? And they're like, oh yeah, but I just created a whole new branch with all of them checked. So maybe this new branch should be the one merged, right? Because this is how things should look like at the end. So, so why not? And people are like, yeah, that sounds cool. Let's merge this one. Now we're going to put all these new changes into master, right? Yeah. And now we go, oh, sorry, git checkout master, we pull, right? So we get all these new changes from it. But now when we go to this other, the first branch we actually opened, when we go down here, we cannot merge because there are conflicts, which means that these changes, these exact changes already happen -1. So, and I can show you how things is going to look like when you click resolve conflicts. So when you look at your branch now, that's basically what it's saying. Like in your branch, which is called check nodes, you have this. On master, it's this. Which one should I do? That's basically what Git is asking. Like, well, I don't understand what's going on. Because first, you made the pull request from master. And you say like, this is the changes. After, you made another one with different changes on the same content. So tell me, what should this pull request now do? And the answer would be, it should be closed. It should not even be merged because it's outdated. We don't want this change anymore. But this is something that a lot of times happen when people change the same file. Because for instance, like I did the change and you would do another change to it. And like if mine gets merged first, then yours gets conflict. And even though sometimes like, yeah, but I actually wanted this change there because we need these features. Like, okay, cool. Then we need now to redo the whole thing. Because now we could say like, oh, but we haven't stopped talking about merge conflicts. So it should actually be the previous one, not the new one. So yeah, that's basically what happens quite a lot, is that whenever you merge something that should not be merged for some reason, and then there is something else waiting for those changes, then it gets conflicts. And conflicts are always represented with this, like the arrow, then equal, then other arrow. And this is also like, it's very easy to find on the code because no programming language has that. So anyone can actually, like if you have a project, you can very easily find, is there merge conflicts? And that's also how Git tells you there is a merge conflict here, because I can see like there is merge conflict here.
Yeah, but my question is, Marco, why I should make a new branch if cannot I edit?
Yes. We could have added this one. That's how we should have done it.
Okay, yes, yeah.
Yeah, and that's the problem. Like by doing a new branch brings problems, and we don't want that.
No, okay.
So if we get asked to do changes, we should always do changes on that branch, and never, oh, I'm going to create a new branch for it. No.
I was supposed to do that. Good thing I did not.
Okay. No, but because again, that might bring these exact problems of, okay, the new branch you created looks good, but technically we should not be a new branch.
No, okay.
and that's the problem of it. It's now everything, like now there is a conflict, and now, yeah, you have to solve that conflict the way that you think, and the best way would be close it, like, because this cannot be merged. This is going to break everything or whatever.
And how we close it?
I mean, in GitHub, you just click here. But, okay, now our master has that, has all the changes, right? Now, let's go to our Git checkout. What was it called? Check notes. So we are on check notes, and in here, everything still feels fine, right? Because, again, it doesn't really know what happened on GitHub, basically. Now, one thing we can, I'll show that. Is it with fetch? No, fetch should not. No. Yeah. What we can do now, it's because we know master changed. So for instance, actually, can we push? Check now. What does it tells us? Come on. Is it for today? No.
And now we make the changes to check notes. What do you have?
Yeah. Now basically what I would like to show is how to handle these merge conflicts locally, because you can do it. Because again, we saw here, oh, there is conflicts there, but I want to, because again, this one, there is this button, resolve conflict, and I mean, this is very easy to understand. It's a text, but now imagine if it's a function, you need to make sure it works, and you cannot make sure it works here, right? You have to have it locally and run the program and everything. So usually you should always resolve conflicts locally if you can, and you should always be able to. So what we're going to do now, and this might sound weird, is that we need now to merge whatever is on master into our branch, not the other way around. So because now master has changes that we know we need to fix those changes, and our branch does not have them. So instead of, because if we say git pull, it's going to say like, no, there is no changes there. Like your branch looks as it used to look before. Master doesn't, but we don't know that. So in order for us to know that, we need to say like, oh, I want whatever is on master, now I want in this branch as well, without messing up master. So in order to do that, you can always run merge And by writing that, of course, we got all these warnings saying like there is conflict. We knew that. We saw it on GitHub, right? And now here, we have exactly the conflict, the same conflict we saw on GitHub. So what we're going to do is we're going to delete what we don't need. And just, again, this is VS Code telling you things, this button here. Because this is regular text that it's written on your code, so you have to delete them. Otherwise, if you have JavaScript or whatever, this won't work. So basically now we need to choose which one do we want. And the one that we actually want, for some reason, we want this because we have not talked about merge conflicts yet fully. So we want our previous. So now if we say git status here, it's a bit longer because it actually says like there is unmerged paths, and that the Git names are very related to trees. Like it's a branch and it's a path and it's a leaf and it's like, so it's very like as a tree related because it makes sense as well. And that's basically what it says here, that there is one path that does not lead anywhere. Like nobody knows where that is going. And that's basically what we just did. There was a conflict, we did some changes, and now what? Now we need to tell Git what exactly do we want. But we know that this is exactly what we want. So now we just need to commit, add, and push everything. So git add first, maybe. Yes. Solve conflicts.
Which should be first, commit or push?
Commit, always. Because if you try to push and you have not committed, it will actually tell you like, I don't know what to push. So, and now we push to the same branch, like as we should have done before. So now if we refresh here, now there is no longer conflicts. And that's what might sound really weird, because on master, right now, we have, is it in notes? Yeah. We have that one checked, right? So the changes are actually like, isn't it the same change we had before? Why is no conflicts there? And the reason why is no conflicts is that if you go here, I mean, yeah, okay, in here it's not that easy to see. No, this one only tells you what happened there. Okay, then we need the command line. Now there is this git log that is, I'll try to explain what's there. So we checked things in the beginning, right? We wrote these check things at that time, exactly. And then we got some notes on GitHub saying like, oh, we should change this. And we created a new branch called new check notes. And we made changes on that branch saying this looks good. We pushed it. We merged that branch into master. And then we had conflicts down here somewhere at this stage, which is not visible anymore because we solved them. But the reason why we had conflicts is because these two parts were somewhere else, were on master. And what we did is like, oh, those changes, bring it to me. So now it's part of my history. So basically we overrode those changes. So we checked things, this one checked one more, and we said, okay, give that to me, and now I'm gonna uncheck it again. And that's why now there is no conflict anymore, because this used to be in master, and it still is in master, but now it's part of our history, which this basically means that as if we started a new branch all over again. We know we started down here, but now we're like, yeah, cool, whatever, you made those changes, I'm gonna make them again. And that's sometimes what's very, very tricky to figure out how that happened in Git. Because now if we merge this one and we go to our source code here, notes, now it's not checked because that's what we did the last time. And when we go to our commits, again, in here we can see, I mean, it's not that visible, but we can understand that we checked the one except the merge conflicts. Then we checked the merge conflicts. We merged it. Then we unchecked it again.
Mm-hmm.
So now it feels like, oh, it was something done in a row, which it wasn't because, oh, we had conflicts. But basically we say like, in order, like the way to solve these conflicts is to say like, okay, the history of master was here and we were here. So then we say like, okay, cool, now I'll go here. So your history is part of mine. And that's basically how conflict solving works. Again, it's something that, for instance, every time there is a lot of changes or whatever, I cannot do everything from scratch. I always use Google to figure out like what to do here, what to do there, because it is a bit complicated and not that easy to understand, sometimes at least. I actually would like to, can we see insights here? No contributors, no community, no. Oh, could I see that comments maybe? Because in some places we can actually see like the tree structure of what happened, and that sometimes is easier to have a visual reference. Why is it taking so long? Come on. Okay, yeah, while that loads. Can we see it as a tree? Unable to show how to see here.
Vi gør opmærksom på, at biblioteket overgår til selvbetjening nu.
Okay.
Please note that we have now entered unstaffed opening hours at the library.
Recording.
No, okay. I don't know how to show that here. And this one is not working for some reason. But usually I think it's the commits one that should show like a tree structure of what we just did, like with a branch name here and then another branch name there. That makes it a bit easier to visualize things.
Before.
Yeah.
Yeah.
But I don't understand why is it not showing, not loading now.
How about the graph?
Hmm?
The graph, dependency graph.
No, that's the libraries that the code has.
Okay.
I don't get it why it does not show that.
Maybe if you close this browser and close it again.
Because in here, no, in here we cannot see anything. Well, I guess it will load eventually. What if we go to GitHub, hack your future React insights. Yeah, why? How come this one shows and that one doesn't? It's a way bigger project. Well, yeah, I don't know.
Maybe because it's connected to your local, it's trying to update.
No. That feels like it's some weird issue.
If you close that
maybe?
page.
Yeah, network. Damn it. This one makes more sense. So, okay, the black one is master. So here, it's what happened last time we had Git.
Yeah.
And today, we started by making a pull request. Actually, we merged to master one time. So as you can see here, that's basically what happened on this dot. Then we made a merge pull request called nodes info, and we checked like everything was nice, merged it. So at this stage we merged. Then we made a merge request called check nodes here, not there, here, and we made some changes to it. And then we got some feedback saying like, oh, you should change that. What we did, we made a new check nodes branch that came from the same place here, as you can see, and we made those changes. And then it's like merge to master, which made these check nodes broken, right? There was merge conflicts there. So basically what we did, and that's this tiny error, we merged master back into it, saying like, okay, because at this stage, they had the same history. Now they don't anymore, because master now is changed, right? There is like a gap here. So basically we said like, okay, now give me all your changes, and I'll make a merge pull request, and now we merge it. So basically that's what we did today here on these steps. And in bigger projects, now how to find a big project.
Your company?
Oh, we don't have it public, so no.
It's not stored in GitHub?
Some parts are, but what you can see there is like very small things, let's say. Okay, this one might be too big because this is the React documentation. What about the Hack Your Future one? Oh, come on. Oh, okay, this does not. Okay. Yeah, but this should show something very similar to it. Yeah, this actually shows all the users that forked the project, basically. Because this is Hack Your Future Copenhagen, and then this is every single user, and the timeline here, it cannot show you everything, otherwise GitHub would go down. Because this is just to have an overview of what happened recently, not like the whole time. But now that I was thinking, if I show you this one that I worked on, but on this one I should not have
recording.
Network, because I always did small. Oh yeah, okay, we can see it. As you can see, like this is pull requests all the time, and they are very ordered because again, it's only me working on this project. So I make one pull request, I merge, then I make another one, I merge, then I make another one, I merge. So in a bigger company or in a bigger project, this would look very, very different, very, very different. No. Okay, I'll try to find something that would look, maybe on my stars I start something that might Gitmoji. Maybe this one. That work. Yeah. Come on. The internet is also really slow. Yeah, okay, in here you can see that more people are working on things. You see, like all that are users, and some of them are like it was never merged, so they are still
Working.
somehow working, or it's ignored. It's like, well, I don't want to do this anymore, whatever. So in here, like, yes, you can have an overview, but it's also like really hard to navigate, because it's also hard to actually show to someone, especially if like there are 20 people working in one project, like how, like you don't have enough space on your screen to show the graph.
it seemed to be that, like here, if you go back a little bit, yeah, can you see that the yellow one?
Mm-hmm.
Yeah, what's mean that?
Yeah, this means that there was a commit
to the branch.
Yeah, another commit. That's basically the same thing that happened here. Here, for instance. So there was a pull request, and then in here there was another commit on this branch, on the branch whatever it was called. There is no name here, because most of them have that dot.
Mm-hmm.
So, for instance, on the other one that I showed, on this one here, network, you can see that some of them have 1, 2, 3. Oh, yeah, if you click on it, you go to the commit message. So it has 1, 2, 3, and basically that means commits that I did to the same branch.
And you push to the branch?
Yes.
Okay. So it's like push, after you push it from your local machine to the branch, it's happening like that?
No, not necessarily. Basically, every time I committed something, like I did the change and now I commit. And now I do more changes and now I commit. And then I only pushed at the end.
So this all commit?
Yes, this is each commit in the branch. Because you can choose to commit every single thing you do. Like you do a little bit and then you commit, do a little bit and then you commit, and then just push at the end. Because keep pushing doesn't make any difference. Because, I mean, it only makes difference because if you might get a conflict. That's the only reason to push all the time. But commit a lot would make sense, because if you're, I don't know, if you're writing this function and it works, before you do something else that might, it would be nice to commit that. So right now, everything that I have committed works, and you don't have to push. You just commit it, like it's saved locally.
Locally.
Yeah. And then when you push to the branch, then it sends a request to the server, like to GitHub, saying like, we want to merge this. And that's sometimes, I mean, I do that a lot. Let's say if, I don't know, like I'm working on something and I'm like, it would be nice if, like, let's say I go home like today, and what if tomorrow, like I might get sick or whatever, and someone else has to finish this. Even though it's not done, I push it, because by pushing it, it's on GitHub. Like someone else can find it. Someone else can say like, oh, I'm gonna keep working on whatever Marco is doing. And by committing it, it's only local. So technically what I do is that during the day, like I pull whatever, is there any changes? Pull everything. Do my work and commit. Every time I have something that I see like, oh, this looks okay, I commit. Then do something else, commit, commit, commit. At the end of the day, I push. So that it's saved, it's somewhere, not only on my machine. Like if my computer burns, it's somewhere, I can still find it. And if I only commit, it's only local. So if somebody steals my computer, all my work was there. Okay. And by pushing, you know, at least it's on your GitHub. Somehow you can still find it somewhere.
Okay, yeah.
And that's really good to again, to keep track of what you're doing, to keep track of your stuff.
What if something happened to GitHub?
Half of the world would burn.
Marco,
yeah, like that's like if Amazon is down, no website would work because a lot of stuff is there. Like there is a lot of those type of problems, right? Like,
okay.
So that's not a. I mean, some people actually ask that question, but it's more like, but I mean, we can trust that. We can trust it's going to work.
Marco, if ever you have a lot of commits and it is saved in your local, so if ever you push, whatever the commit is, the last or the latest will just be the one that will be pushed on the GitHub or everything?
No, every single commit will be pushed. So for instance, now here, let's check out the master. We have everything merged, I think, right? Yes, okay. So now, should be simple branch. Yeah. So now I'm gonna do changes on this temp, just for some reason. So I'm gonna remove everything and say item 1. Now this one has a change, so I can say git commit, added item 1. So now this commit is there. So if we run the status, it's like everything's cool. So now I add item 2. Now if I run git status, there is a change. So git commit item 2. So now, again, just by running the git log here, like locally, I can see like there is this commit, there is this commit. So whatever I push, I'm going to push them not separately. I'm going to push them at once, but all of it is going to be visible. So if, just for the sake of it, to see how it's going to look like on a graph, 3, now we're going to push it. Now when we go here, there is something we pushed. Now even before we create our pull request, we can actually see here there is 3 commits on this entire thing, even though we only see it as if it's one change. And but if we click on each one of them, then we can see, oh, commit added item 1, we added item 1. Now we go back. Yeah, item 2. Item 1 was already there, we added item 2. So all this history is going to be saved there, all of it. So now we create this. And again, in here, whoever is going to look at your pull request can actually see, like, oh, at this step, you did only this change. So this is also it's also very useful for the people to look at it. Because if you make a commit, let's say, per function or per, in React, for instance, like, oh, I developed this component and I think it works, I'm going to commit it. So people who look at it can see, like, oh, this component, like, that's the change you did. So I don't care about the rest of the website. I only care about the component you did here. So it's more unique on looking at it, at things. Now, if we merge this thing, it's merged. Now, if we go to Insights and Network, yeah, okay. Now in here we can actually see every commit we did, basically. Oh, yeah, added item 1, added item 2, added item 3. Yes. So everything gets stored in the history of your entire project. Which again, this is really, really useful to when something goes wrong, or when, again, sometimes, like, and that happens a lot, at least for me, you have to solve something on your code. You have to create a function that does something. You do that. If you think, like, I might have the same problem, like I won't remember how I did it in the future. If you commit that with a specific name, saying like this function does that, then very easily on your GitHub, if one day, like in a few months, you have to do the same exact function, you just go here and you try to find it. And then you have exactly the solution you did some time ago, right there on your commit. So I mean, I use it for my own documentation. Useful. Yeah, it is, because then you don't need to trust what you find on the internet, whatever. You already solved it, and it's normal not to remember. Yeah. I mean, I don't remember shit I do. Like, you cannot remember that stuff. So it is very useful for that, because then you can easily find it. Like, all your documentation is here. So.
Can we hold a pause for 5 to 10 minutes?
Yeah, we'll make a break now. Let me just check here. Yeah, and then we will do everything from scratch, basically. So let's make a break.